Okay, everyone. So now we are learning the file handling. To understand the file handling, I am taking the example here. Let us suppose that we are having is the CPU in our system. We know that CPU perform all the operation. We are assuming that here we are having the keyboard. With the help of keyboard, we can take the input, and we are having the monitor. With the help of that, we can provide the output of the program. CPU is linked with the primary memory. Primary memory in the short is also called memory. When somebody say you memory, that means it is talking about the primary memory. Primary memory is also called RAM. RAM is the random access memory where CPU store the data whenever it requires. So CPU deal with the primary memory directly. And primary memory further have the secondary memory. Secondary memory is also called disk or the hard disk. In today's world, we are having the various secondary memory, just like we are having is the pen drive, we are having is the SSD, which is the solid state drive, or various hard drives. So they all are the example of secondary memory. The size of secondary memory is very large, but the speed is slow. So CPU don't work with the secondary memory directly. CPU work with the primary memory. But let us suppose that I am going to make a C program and I am going to save into the C drive. We know that C drive is the part of secondary memory. Let us suppose that I have saved this file with the name, let's say Ankit. And this is the C program file. So this is ankit.c. Here we are talking about the C program. So this is the C program file. Now it is saved to the C drive, and C drive is of secondary memory. Let us assume that in that we are having some program containing the void main library functions, but mainly let's assume that we are having is the variable. Let's say the variable name is int a. So a is the variable of integer type. Let us suppose that its value I am taking from the user, and for the user we know that we need the scanf statement, and in the bracket we use the %d, and at the address of a we are going to store that. So this is how we code. And let us suppose that in this C program again I want to print. So I am saying simply printf, means printing on the screen. And for printing the integer, we know that %d for the integer. Now comma, we are taking the a. So this is a simple program for taking the input of a and showing the output. This is a C program stored into the disk or secondary memory or the hard drive. After creating the C program, which is ankit.c, now we are going to compile this program. We know that compilation means checking the error. Let us suppose that there is no error. Compilation successful. The next part is running this code, means executing. While we are executing this code, then the first line is int a. One thing to note, whenever we are having some variable inside the secondary memory, those variable will be declared inside the primary memory. Means inside the primary memory, we will be having the variable. Let us suppose that that variable name is a. It is having, let's say, some address, maybe 301. So inside the primary memory, that variable is declared. Although the complete program will come to the primary memory for a while so that CPU can fetch it. So the variable will be declared inside the primary only. Now afterward, the next line will be scanf, means taking the input from the user, %d for the integer value. So here it is asking the instruction to the user that give the input. With the help of keyboard, let's say user is giving the input. Let's assume that the input is 5. So this 5 number is given by the keyboard. Now CPU just store that number to the primary memory. So inside the primary memory, we are having the variable a. So in the variable a, we are having the value which is 5. Now afterward in the C program, next line is that printf, means printing on the screen, %d for the integer a. So here the value of a, that is 5, that will be displayed on the monitor and user can see that. So on the monitor we are having the output which is 5. Later on we are going to close the program. Let's say we have closed the program which is ankit.c. Now after what is going to happen? Inside the secondary memory, program will persist because secondary memory, or we say hard disk, that is the non-volatile. But our primary memory, which is a RAM, that is volatile. Non-volatile means whenever we are saving some data inside the primary memory, that doesn't lost, means that persists always. But if we talk about the volatile, means inside the primary memory, the data will lost. So that means in the keyboard we have given the value which is 5. So inside the primary memory, everything got lost. Means that variable A and its value is not available. Let us suppose on the next day I am coming and again I am running this Ankit.c program. So again everything will be with the same as the previous. Again int A means one variable will be declared, that is, let's say A, that maybe its memory got changed, maybe 401. Again scanf. So again we are asking the user for the value. User will again provide the value, let's say 5, one more time. So here we cannot fetch the previous program value. Means every time we are executing the program, the previous values got lost. So here this 5 value is saved inside the variable A. So this is the value which is 5. Then again we are fetching that value. So printf is printing on the screen. Then %d for the integer values A. So here again on the monitor we are displaying the value 5. Again I am coming on the next day. Then again every time I has to do the same steps. But the values which I have given, let's say this value 5 we have given first time. So these values will not persist. So every time we have to give this value again and again. So these value will not there because the primary memory is the volatile, means the data will lost. And here the variables which we are storing, that are keep on losing every time. Let us suppose that today I am giving some input. Tomorrow I will come, that input is not there. So that's why we are having the file handling. So now we are learning that what is the need of file handling. So here we need the file handling because the memory is volatile and its content would be lost once the program is terminated. So here we are talking about the primary memory. Whenever we are saying the memory, that means we are talking about the primary memory. Our primary memory is volatile. Volatile means whenever the program is over, the data will lost. So when the program terminate, then the data will be lost. That means all the variable we are declared, their value, they will be lost. That means every time we has to come and redeclare the variable, take the value, so their value we cannot fetch. So that is really a problem. There is one more reason because of that we need the file handling. We can see that here the memory is having less amount of size. And here we can store the limited data. So inside the primary memory, we are having the limited size as compared to the secondary memory. We know that secondary memory is the hard disk, which is of 1 TB, means terabyte, or maybe 512 GB, gigabyte. But primary memory is of, let's say, 8 GB. So here today we have the 8 GB of primary memory and maybe 1 TB of secondary memory. We know that terabyte is larger. So inside the secondary memory we can store much data, but in primary memory the space is limited. So that is the reason that in the primary memory we cannot store large amount of data. So limited amount of data can be stored inside the memory. So inside the primary memory we can store the limited data, let's say 8 GB as compared to the secondary memory. In the secondary memory we are having the 1 TB. So here limited size of memory, and second thing is limited amount of data can be displayed on the screen. On the screen we cannot display everything. So on the monitor we can only show the few records. So that's why we need a place where we can store everything, and that is the file. And file is stored into the secondary memory. So let us suppose that we are creating one file into the secondary memory and see how the program will work. Now we are learning the same example with the file handling. Let us suppose that inside the secondary memory or say disk, we are having is the file which is Ankit.c. So here is a C program saved. Now we are going to execute the program. So here the first part is int a. That means variable will be declared. We know that variable are declared inside the primary memory. So here inside the primary memory, let's say one block a is reserved. Let's say the address is 301. Afterward, the next line of the program is scanf, means taking the input from the user, and %d, that is for the integer value. So from the keyboard, we are asking the user that please give me some input. So user is giving an input, let us say 5. That 5 we are storing at the address of A. So at the address of A, we are going to store this 5. This is stored inside the primary memory. Now afterward, we are going to print this. So printf means printing on the screen. %d for the integer value a. So the value of a, which is 5, we are displaying on the monitor. Now afterward, we are using some file handling. Let us suppose that some file handling program we are writing. Now inside the secondary memory, we are creating one file. Let's say the name of file is file.txt. So txt is the extension. That means it is the text file. Now using some C programming code, we are going to store the value 5 which is in the primary memory. That value we are going to store inside the secondary memory file. So here inside the secondary memory, the file we are going to store the value which is 5. So file got saved. Now we are going to terminate our program. So here Ankit.c program we are terminating. We know that once we terminate the program, then inside the primary memory, everything got lost. So their variable declaration and its value, everything got lost because the primary memory is the volatile memory. Let's say tomorrow I am coming. Again, I am opening the C program, which is Ankit.c. Again, I am saying int a. So let's say the variable is declared inside the primary memory, which is a. Maybe some address is given, which is 401. Let's say here, I am not using the scanf directly. First of all, I am using some file handling functions. So with the help of that, I am using the file.txt. So here this file.txt I am using, and that value I am taking and I am storing inside the variable a. So here the value 5, we are now not taking from the user again. We are taking the previous value and we are going to store it here. So here we can see that using the file handling, we are going to take the value which is 5. That 5 value we are storing again to the primary memory. Now in the program, we can display that or we can modify the value, whatever we want. So with the help of the file handling, we are storing the data in secondary memory or say disk or maybe the floppy disk, hard drive, SSD, means that is the secondary memory, and we know that secondary memory is the non-volatile. So here in the file handling, we create the file and the file is the part of secondary memory which is non-volatile, means data will not lost. Even you terminate the program, data will be there. So if you want to store some important data of your C program and you want to fetch later on, then you can use the file handling. So here we are having is the definition of file, that the file store data or the stream of character in disk. Definition of file says that it store data. Data means the stream of character. So that means file can store the characters together, and that is called data. And these data should be stored inside the disk. We know that disk is the secondary memory, which is the non-volatile memory. So here file contain data, which is the stream of character and which is the part of disk, that is the non-volatile memory. So here data will not lost. So we can say that file are non-volatile and its content persist, because the files we are going to save inside the secondary memory, and the secondary memory is non-volatile. That's why the files are non-volatile. Non-volatile means their data will not lost. Even the program terminate, even you switch off the system, even then the data will remain there. So that is called non-volatile. So their data will not lost. They are non-volatile and their content persists. So their content will remain as it is. So here inside that we have saved the data which is 5. So that 5 will be saved and whenever you want, you can fetch that data. So whenever you want to store some important data in the C programming, then you need the file handling so that that file should be saved to the secondary memory and you can retrieve that data whenever you want. Now we are learning the file operations. There are various operations which we can perform on the file. That means the first operation we are having is create new file. So using the C program, you can create a file. Then afterward, you can perform the next operation. That means you can open that file. After opening the file, you can read the file. So the next operation is reading the file. After reading, if you want to modify that file, you can modify it, or you can write that file, you can write it. So here, next operation is write the file. If inside the file you want to search something, that is called seek. So you can seek the file. This is the next operation where you can move to the specific location in the file. And after doing all the operation, we are having the last operation which is closing the file. So in the file operation, we can create file, we can open the file, we can read the file, write the file, we can move to a specific location, means seek the file, or we can close the file. So that is all about the file operations.